Hi, this is MPLS Consulting, and we are working on the Peachtree Corner Circle and West Jones Bridge Road intersection improvement. Our team consists of Samuel Cushman, Phoebe Ellis, Megan McGurk, and Lauren Sisk. First, a background. Our site is located in Peachtree Corners, Georgia, in Gwinnett County. Here is an image showing where our site is located compared to the Georgia Tech campus. Our site has a YMCA, a church athletic fields, and school surrounding the intersection itself. The first problem we noticed is the performance limitations of our intersection. Level of service is a way to grade how well an intersection is performing. Level of service A is free flow conditions with the intersection performing very well. Level of service F is really a failing intersection with it performing very poorly. One of our approaches has a level of service of E and another has a level of service of D. This shows how our intersection is not performing very well. We also found safety issues regarding to the school nearby, with children playing with recess equipment very nearby, and also crossing the street in a diagonal way as shown in figure 6 here. It is just a safety concern. Thus, for our design objectives, we first wanted to improve the efficiency of this intersection and have all the approaches be a level of service of C or above. We also wanted to enhance the safety and ensure that there are multiple ways to cross this intersection safely for the children, and just ensure that cars are traveling in a slow and safe way for everyone involved.
In order to address our concerns, the team decided on a displaced left turn intersection design. A displaced left turn is an innovative design that is able to address safety and level of service objectives. The displaced left turn at a T intersection such as ours allows for a decrease in conflict points and an increase in throughput. The image on the left shows a current model of a displaced left turn at a three-leg intersection in New York, and the image on the right is our displaced left turn VISIM model. In order to model our intersection in VISIM, we drew the displaced left turn geometry and tied it into the existing geometry on the road. Speed, volume, and routing inputs were kept the same as the existing intersection model as we had observed them during our site visit. To prioritize safety for pedestrians, we added a new crosswalk and extended the median. Therefore, the number of lanes that pedestrian must cross was decreased. The pedestrians also have a pedestrian-only signal phase. In order to reduce driver confusion through the intersection, we kept the westbound through lane as straight as possible. We channelized the westbound right turn to reduce merging conflicts with the northbound traffic. Now, the southbound and westbound right turns are free flow unless the pedestrian phase is called. Figures 10, 11, and 12 show 3 different scenarios for our signals. As stated previously, the westbound and southbound right turns are always green unless the pedestrian phase is called. The eastbound through, eastbound left, and westbound through traffic have green lights at the same time. Then the eastbound displaced left turn crossover is green while the southbound left turn is green. Following our VISIM model, we created our design in Open Roads.
For the Open Roads design of our project, we modeled a full 2D design in Bentley Open Roads displaying construction layout, typical sections, pavement areas, and more. We use resources such as the VISIM model, design criteria, and the GDOT Design Policy Manual and the ASHTO Green Book. The construction layout was built upon the VISIM concept design, taking into account specific geometries and expansions along sections of the road that utilize our innovative design. Compiling our design materials and resources using the GDOT item means summary, we formulated a cost estimate with respect to labor and materials that tallied each category of factors within our project. Signing, traffic control, roadway, pavement, erosion control, and right-of-way usage totaled to a complete cost of $1,400,000.
Moving into an evaluation of our design, we decided to create a minimal build alternative to compare our redesign against. This is a cheaper alternative at only $12,000. It adds a new crosswalk on the far side of the intersection to improve pedestrian safety, and it improves level of services by adjusting the existing signal timing. However, these are pretty minimal improvements compared to a full redesign. You can see here a comparison of the existing displaced left turn and minimal build alternatives. As you can see, the displaced left turn raises all level of services to be a C or better, and the minimal build does provide some level of service increases. However, there are still 2 approaches with a level of service of D. The displaced left turn has a cost of $1.4 million, while the minimal build is only $12,000. And the displaced left turn also improves safety more because it improves pedestrian safety while also decreasing the number of conflict points through the intersection. The minimal build is still slightly safer for pedestrians than the existing conditions because of the addition of the new crosswalk. To conclude, we would recommend implementation of the displaced left turn alternative because not only does it improve level of services, but it also addresses pedestrian safety concerns. However, for a lower budget, short-term option, The minimal build alternative does provide some slight delay decreases and slightly safer pedestrian crossing conditions. You can see that option modeled in open roads in figure 16. Thank you.